audio in there. I think I do. All right, so one of the things when we get back in here is, unfortunately, our computers are not as bright as we think they are, and the computers work only in binary. And binary really is just zeros and ones, ons or offs, and your computer is really nothing more than a set of light switches. Well, the book makes a lot out of how to convert back and forth, and there is some value to being able to do it by hand, but for this particular class at this particular time, I want us to really think about how I can convert that easily. And so I'm going to show you the shortcut cheater trick. It is handy when you get into some other courses to know how to do this on your own, but let me show you a tool that's included with any version of Windows, and Mac has something similar. But if I bring up the calculator, of course it's going to be in the wrong one. If I bring up the calculator, which is huge on this screen right now, and I change its mode, so instead of a standard calculator, I go down here to programmer. Well, now I can put in any value, and it will automatically show me over here on the left what that is in hexadecimal, which is base 16, decimal, which is where we're starting at, octal, which is base 8, or in binary. And so it's a really great way to do that. And so if I click on binary, I can then put in a number. Notice it grays out everything except zeros and ones, so I can't even make a mistake when I put one in. So there's one in binary. So 1111110 whatever here is equal to decimal 120. So we can see that if we had 2, 3, 4, 5, 6, 7, 8. So if I have all ones, the biggest number I can make in an 8-bit, so a single 0 or 1 is a bit. Putting them together in a block of 8 makes something called a byte, B-Y-T-E. Notice it says, so it's binary, it's all the ones. In decimal, it's 255, or in hexadecimal, FF. But this number we see a lot. So it really says it's decimal 255, or 256 positions between 0 and 255. And we see these kinds of values all the time in the world around us. If we go buy a television, it'll say, hey, this is 64-bit color. Or if we go buy a new gaming station, you'll see these representations. So I want to make sure we know how to convert back and forth. And this is a quick, handy way to do it until you get familiar with how to convert back and forth. Now, when we get in some other classes where you need to understand that a little more in depth, we'll actually show you some manual ways to do that. So the book shows you how you could convert back and forth programmatically, which is kind of an interesting thing to do. So you might want to try that. So decimal to binary. And so if we're going to do it by hand, there's some methods we do it where we're continually dividing by 2. Well, our computer can then do the same thing. So here we're splitting it up. Here we're just showing the positions. So here's octal, which is base 8, which we don't really use a huge amount anymore. It was kind of an interim step, so it was an easier number to deal with for us than all the zeros and ones. Typically now we either use binary directly or we use hexadecimal in most of our programming code. So here's hexadecimal, which is base 16. So we have not only the letter numbers 0 through 9, but we have A through F also to make it a base 16. All right. In our string methods, so we call method is really kind of the same idea as a function. So we're taking a function and putting it directly into some of our language, which is really interesting. So in this case, we have a variable here called sentence. And here we're actually creating a method, and you're using something called sentence.split. So anytime you see the dot, typically that means we're doing some kind of a method. So really basically, there's a whole ton of these that we can apply to our variables. splits one of them, uppercase, lowercase, mixed case, all different kinds of things we can convert directly. So when we want to use something like this string method, so here we say we're putting in a sentence, and here's the sentence they put in there. And what we want to find out is how many words there are in it. So if I were to count 1, 2, 3, 4, 5, 6, 7, 8, 9 words, I get something different. Oh, sorry, my bad here. 1, 2, 3, 4, 5, 6. I was like, wait a minute, that was weird. All right, so we can actually use the split to see then it splits it into chunks, and we can actually do then that length for something called the list of words, this second variable we created. And then we can do that to see that there are 6 words. 6 different words in there. So we can also then, you could convert, you could say what's the average length of our text. So there's a lot of different string methods we're going to use throughout the rest of this. If I'm curious, one of the things our book tells you to do is you can reference those. Well, Google is your friend. So if I put into Google string methods Python, I get a whole list of them. So I can capitalize, count, ends with. So I can check and see if it ends with a specific value. I can format them in a huge number of different ways. So, and this is not probably a complete list. Here, splits the string at a specified separator, splits a line at line breaks, returns a trimmed version so we can strip out pieces if we want to, swap cases where lower becomes upper and upper becomes lower, title, translate. So there's a huge number of different methods that are available. You don't have to remember them all. You just need to remember, hey, there is something that can do this. Now I can go figure out what it is I need to do. And if I want to look at one of these, so let's say I want to capitalize, it'll actually give me an example here. So text equals hello, welcome to my world. Here we said, we assigned it a new value, so x equals text.capitalize. And we can even try it here, and you can run it inside of Python World's little handy dandy, very slow. And notice it changed it. It capitalized the beginning of the sentence. So we can try those. There's a lot of different resources out there for constructing some of these items. Get that out of the way. So string methods, it's really a kind of a function. And it's using those dotted notations. More importantly, this chapter also starts talking about how we can convert something to a file and actually store that. So if I just input data, and Python can store that data in a pretty good size amount of data, but the problem is it's temporary. When Python restarts, it's gone. So text files, or the ability to read and write to that hard drive, give us the ability to store data more permanently. So we can write files, and the easiest way we start out with is the idea of a text file. So a .txt, and you can actually create your own using Notepad. So we can take data, use it over and over and over again. So a text file is going to look something like this. It's just going to have a set of numbers. So if I did Notepad, and Notepad's probably one of my favorite tools in here. So that is a set of numbers we could store in Notepad. And then our program could come over, grab those back out of that program, and take a look at them and output them to us. So, a couple of things we have to remember about reading and writing to hard drives or to other storage medium. So before we output it, it has to be converted to a string. So everything we do when we put it into Notepad, like our guy here, is really the idea of a string of text. And that's what we're storing. So just like when we do an input, everything has to be a string. And we have some specific nomenclature we need to look at really quickly here. So, to open a file, so here we say, here's our line, F equals open. And open is actually now, it's doing something. And what we're doing is we're creating a file called myfile.txt, and we're creating it with a specific type of method. So this W stands for write. That says, hey, we're going to write it. Using this method, that file is written automatically. If it doesn't exist, it's written. If there is one already existing with that name, it wipes it out. So we'll look at some other types, but we'll take a look at these and see if we can figure out where we're at here. So if I already had a file and I did this command, it wipes it out. So there, we'll have to look at something like an append. So we have to open and we have to close our files all the time. So to make it a little more clear, let's open up idle. And so this is our interactive mode. So if I do the same thing, so I say F equals open, and I put in a file name. So txt, and then I use the method write. All right, that's going to open that file. And so it just created that file. Now, I should have probably stored this somewhere else, but right now it's stored in my default location. So I don't know where that's at right now, but I can find it here in a second. So I want to actually put something in there. I can use, so that method f.write, and now I can actually put in text. First item in file. And I can also use those embedded streams, and I could actually say second item. All right, so when I run this, it's actually going to take that and put it into that text file. And then I do this, I say f.close. I always have to close that, otherwise it keeps that file open. So now, let's see if I can find out where Python stored that one handily for me. What did I call it? myfile.txt. Search for it real quick. And it may have stored it somewhere really, truly odd at this point, because I just opened up idle and I didn't point it to a specific location. And when you're using idle on your own system, that's one of the things you have to be careful of, is where am I actually storing these at. So I would want to typically open up a program in a known location. When you are using Cengage, Cengage happily sets it up here. It puts it in this big pile for me, and we don't have to worry about its location as much. So it probably stored it in some of the temp app data. So we'll take a look at it, and I'll try to find an example here that'll make it a little easier for you. Close that for now. So writing text isn't that hard. We write it to the file. We can then go back in and read it using a very similar nomenclature. So if I'm going to write numbers, remember I have to convert those numbers to a string. So here I've done that f.write, and I've used the string command then to convert it to a number. So anytime I want to write numbers, I have to convert them to a string. So here we opened one called integers.txt, and we did a for loop. So that for loop then is going to create a count, and we had 500 random numbers in here. Well, if I do this, and I'll just grab this little piece of code right here, and I will fire up idle. So we're going to create a new file. So this one's actually going to run as a batch script. And I think that's a little better, an easier way for me to run it. So imports random, opens integers.txt. So here's the key. I'm going to save it somewhere. So I'm going to save as, so I can put it in a location where I know where it's at. I'm going to call it Python programs, and I'm going to make a new folder. So I'm going to call that my test folder, and I'm going to put this program in here. So integer, right, trying to shorten it up here a little bit. So now I have a program and it's stored, and I know where it's stored at. So now when I run this, so it says, wait, open integers.txt. So why did it not like that? Let's try another name. Seemed to be an issue with the name integers there. Why am I making it mad? Can't see my screen up here. Sample.txt. Right. Import random. What do I have weird in there, Quade? Let me pause that for a second. All right. So what we figured out really quickly is it didn't like when I copied. So let me just come down here. Out of the book, it actually uses the quote marks correctly in the way that they've printed it. Well, the problem is it doesn't recognize those quote marks. So I had to go in and substitute in the single and the double quotes the way the computer wants them instead of what it is as a standard text. So now if I run this, to do that also. All right, run. Same issue. Chunk. All right. All right, so now it said, all right, we opened a file, we wrote in an item, and we closed it. So we can go in and we can go look at that then, and we can see what that file looks like. So I open up Internet Explorer. I go to Documents where that's at, and I go into my test folder. And so here's the program, and then here's the sample text. And so let's see what it looks like. It wrote 1. So obviously we have a programming issue of some sort, but it did write a file and create a text. Well, let's see there. Let's run it again just to see what happens. All right. It ran. Let's take a look at that text again and see if it really did overwrite it. And notice it did. It created another random number. So it overwrites those files. So that's one of the dangerous things we can do in here is we can overwrite that file accidentally. Oh, that's got to be in the... All right, so now we'll do it again. All right, and now we'll take a look at our text file. And now we should have 500 semi-random numbers for us to utilize. And each time we run this, it's going to put 500 different numbers in there, separate numbers. So I can write that file, and so here it is in the same location, so same folder as where my program is. So it runs, and it pulled 500 random numbers, and it wrote those then, converted them to a string, and it used a new line character. So if I eliminated that, yep, okay. Run module, and now I go look at my sample text. Well, it's 500 random numbers, but we didn't separate them in any way. So it just said, hey, I'm going to keep adding to this text file, and it just wrote them all consecutively. Well, that's not very handy. That's not necessarily what we were looking for. But it shows us how quickly and easily we can change some of those. So if we can write to this file, we need to figure out how we can read from that very same file. So the write says I'm going to write something to it. In this case, here we're putting numbers in there. If I want to read it, I have to do something similar. In this case, I open it, and I say f equals, and you don't have to necessarily use f, that's just a variable. You say open myfile.txt, comma, r. And so we're using the read method. So we read it, and now we have to come out and figure out how we're going to open this file. So if we looked very similar and we said, all right, I want to open this file that I had earlier, I have to come up with a way to do that. And we can do it in a lot of different ways. So there are some read methods. So if we get to the end of our file, that read says, hey, it returns something that's empty. So open, and if we use a loop like while true, we can use read lines, and we can open this file one line at a time. So we don't necessarily have to open that entire file. We can actually open it one line or two or three at a time because we use this f.read line. And so if I constructed it, where I still had the new line character, so now I created this list of 500 integers, I could go back in and I could read them one line at a time, and I could get that output one line at a time. So if I put in something else, I could actually read them then by groups, and so we'll look at an example of that. So here we're reading numbers, so it works the same way. They're reading here. In this case, we opened up integers. Here's our for loop for line in F. So every time it goes through, it reads one more line into this. So we can read them consecutively. So a couple of methods. So open, obviously we open that file whether we're going to read it, write it. So the last two here, read, write, or A means append. So read, write means we can do either read or writes with it. So if we're keeping that file open, we're adding to it and then we're reading it and adding to it. That's a model we can do. The append is kind of nice. So if we created a program that stored high scores, for example, we could use an append and just keep adding a score onto the end of that file. And then read line and read. So read grabs the entire thing, and read line, we can get each individual line of text out of there easily. So the book goes into maintaining files and how you would try to look at those. Well, if I need to get outside of that single directory, so let's see, do I have that open still? Yes. So if I need outside of this, because I wanted to put that file up one level, I can actually use some dotted notations to get up into the parent, or I can go down in files. We're not going to make you do that. Anything we're going to do with a file, you can put in the same file structure as your main idle file, or we're doing it in Cengage, which keeps it all in the same area. So you'll see this same thing when you get into web design and some other courses about how we do those and how we move things around. So we actually have all kinds of ways to manipulate files. It's a little past where I want to go here in this particular class, but if you're working with Python and you do it a lot, those models are kind of nice to do that. So we can also look at path names and files, and you can return logical summaries. So there's a lot of information in this chapter, and we're going to try to to minimize it here a little bit. So what I would like to do is, I'd like to point out one thing really quickly. So you should probably, I guess, this one here goes through, where's it popping up at? The magical mystery pop-ups here. So in this case study, so this doesn't give you any points, but it is a really good iterative way to come through this chapter and to look at this text analysis program. So in this case, what you're doing is doing finally you're open. All right. So there's a couple of programs that you're looking at here. So this creates an index, and it says, all right, I need to know how many sentences there are, how many words, how many syllables, and it will create a scale. So we use this index to calculate reading scores and reading levels. So nobody goes through and looks at a book and says, oh, this is a reading level 5. They use actually a scale like this, and it creates this level that says, this is what my grade level is. And so if I run this, and so I say, well, we have 100 sentences, and it's 480 words, and let's do 600 syllables. That's going to say, oh, its index is 94 or grade level of 1. So what it's doing is it's basing this on an index score based on how many words versus how many syllables. In other words, the more syllables you put in, so if we did it again, so 100, and I think I said 480 before, but now I do 1560 for syllables. Now it's going to say, hey, it's a grade score of 25. So it's an arbitrary number then when we get in there based on the number of syllables and you use per word. So here we have a program then that takes a file. So if you take like a graduate level document, you upload it, and this actually creates that ability to do that. And so you can look and see how it splits up things based on by vowels to split it into number of syllables. So these are really handy to go through, and you can actually put in some text files of your own. But you also see this, you can actually see these same scores if you go into Word on a document, and you can see that there are some scores for those. All right, so if I look at programming assignment 4.8, and we start that assignment, get the wipes out of my way so I can actually see the screen. All right, so let's take a look at programming exercise 4.8. And so 4.8 says, all right, here's my directions. We're going to write a program, and we're going to write a script called copyfile.py. All right, luckily they named it for us already. And it prompts the user for the names of 2 text files, and the content of the first file should be input and written to the second file. All right, so we know we have to get a couple of inputs. So inputs from user. So I'm just going to kind of highlight that so we can see what it is. And so the first one, so I might call this file, what would we call it? File in, maybe? And so we're going to take an input from the user. We're going to say, all right, please enter the file to copy. And then they're going to give us a name. And then file copy is then going to be very similar. We're going to say input please enter the file name to be copied to, or some such similar thing. So I can actually run that now, see if it works. Chunk. Now, the file names I just entered in there aren't obviously going to work because we have to have a couple of pieces. And right now we don't have enough skills or enough pieces learned to verify those yet. So we could end up with a weird issue when we're doing this. So the first thing we're going to have to do then is we're going to have to take the file to be copied. And so we could call that our file. What would we want to call it? We call that file in. Let's call it file in data. So we're going to take in this information and we're going to do something with it. So we're going to have to open a file. And the file name we're going to open it is the one we put in earlier. So file in. So hopefully they put in the right name or we're going to get an error. And then because we're not going to write to it, we're just going to read. We're just going to open that as a read. So we've opened it. It's sitting there open, available for us to use it. And then we can use just a temporary variable. So in this case, I'm going to call it temp. And we're going to say then it's our name of our file. So file in data. And we're going to use that dot notation read. So that should move everything from this file that we've typed in first into this temp folder here. So I'm going to run it and just see what it does to start with. File name to copy. So I'm going to call it copy file.py. So I'm going to type it correctly the first time and see what happens. All right. And it's going to get an error of some such. So what did I do wrong? So notice here where it says copy file, it is case sensitive. So let me run it again real quick. The file to copy is copy file.py. All right, so it seems to have not had an error. It opened it apparently. And if I were to do this, so print temp, we could do this again and we could see if it's going to print out the copy of whatever's in there. So enter the copy file, copy file.py. Doesn't matter what I call this because it's not doing anything yet. So here it actually showed me what's inside this file name right there. So that's pretty cool. That's what I've been typing, and it actually just put it out on the screen. All right. So we can read and write to Python files also, which is kind of a handy thing to do. All right. So I know I don't need this anymore because I just used that as a test. Is it opening that file and reading the whole thing? So now I have to figure out how do I write this file then to this address. Well, one of the things that I need to do is we need to figure out what that file is. So we could call this file out, file copy. We used file copy already, so file out. So now we're going to use the same nomenclature. So we're going to open. And in this case, because what we're opening is the one we're going to output it to, file copy from using this one up above. And this time we're going to do it as a write So now we're gonna create one, and we're gonna put text into it. So if we're gonna do that, then we can use that same thing. So file out, and we'll use our dot notation, and we're gonna write to it. And what we're gonna write is that file we stored in temp. So we're gonna take all this data here we grabbed in temp, and we're gonna write it out. Now, this actually should work. Here's a problem with it. So we've opened two different files, and neither one of them have we closed. So here, we really need to close that same thing. So we need to do file in data.close. That way we close our file we've opened up here. And the same way down here, dot close. Now, will the program work if I don't close those? Yes. But it's kind of an important thing as you get a lot of files open, make sure they're closed. That way the program doesn't write extraneous data to them. So now we can go through and we can see, does this actually function the way we thought it would? So I'm going to hit run code. Now, in this case, I have to be very careful and type the correct names. So the first one is copy. Let's actually do this. Let's see if we can. So the file to copy. Let's just start over with a new. There we go. File to copy is copy file.py. Did I spell that right? Yep. All right. Enter the name. What is the name? Hang on. Let me move it back just slightly so I can see the name of it. So the output name should be copy2.text. And let's see then what happens when we hit run. And apparently it didn't like that for some reason. Let me look. Or it did it, and because we don't have any positive output there, so I hit run again. All right. So script should prompt the user for the names of two files. The first file should be input and written to the second. So enter the input file, and we'll call that. I'll start it over and make sure I didn't type anything in there. So the file we're going to use is copy from.txt, and we're going to copy to.txt. And it seems to execute. So in that case, we can go over and we can look at, and we can actually run our checks. Does it work? Total of 1 of 2 passes. So what does it not like? Check contents of text file. So why is it wanting us to check that? Hang on, let me see what it is not liking about us. Check contents of text file 2. Oh, when I ran that earlier, I think so it created the file, but I had messed up the text file by playing with it. So that one should be okay once you come back out and actually check it. So it actually evaluates that, and I had modified what's actually stored in there. So that should actually be fine for you when you do it. All right, so 4.8 is that idea of we're copying files over. So we should have most of the pieces for that. 4-10 go sometime. All right. So let's look quickly at 4-10 and see if we can figure out what we're looking for here. All right. So here, we're actually looking at, we're going to create a file, and we're going to try to look at two files, and we're going to see if we can tell the difference between the two of them. So we're going to create some way to go look at two different files, and it gives us some names of ones that we're able to use in here. So we're going to write one called difference.py. So you're going to get the name of two text files. You're going to compare the contents, and we're going to check to see if they're the same. So I already closed it. I was going to say what we could do is actually grab some content from the very first one we did, but we can do that again because we know that the very first thing we're going to need to do is get those file names. So we should be familiar with that. So file 1, we're going to use an input and say, please enter file 1. Input, please enter file 2. All right, so we've got our two files. So now we need to open those files. So I'm actually going to block it off so I can see that. I'm going to say open files because we're going to open these two files for reading. So input file 1, and so we're going to create an open for that. So open, and we called it file 1, file 1, and we're going to do it with just this read method because all we want to do is read it. We don't necessarily need to do anything else with it. Well, I like that line so much, I'm just going to put it down here again because we also have to open up that second file. So input file 2 equals open file 2. And that R for a read only. So, well, that's doing pretty good. So now we need to think about how do I compare those two files together. So let's think about how we could compare them because we know that we can read them one line at a time. And so I could, let's do this. Line 1 is equal to, what did I call it? Input file 1 dot read line. And so what I'm doing is I'm opening up, let me just copy this. So input line 2, file 2. So now I have two different lines opened up from two different files, and I can compare them. So I could say, I could put an if. So if line 1 is equal to line 2, and the true side would be print equal. We'll put that in. And then the else then would be print not equal. So this, if I run this, so we have a couple of different files that we're able to use. So we could look at them. What are the names here? It's different from 1, same as 1, 1.txt. Okay. So if I run this and I haven't done anything else stupid, we can look at it and we can look at least one line and we can see what happens. So please enter the file name, which is one.txt, and the other one should be same as 1. All right, what did I do wrong? File not found. So in other words, I probably typed the name wrong somehow in there, so it did not grab the right name, because it says, oh, we have an error and it gives us some information, no such file or directory, one.txt. We should be able to see one.txt. Maybe we're not allowed to. Do we have to create? All right, hang on. Do you guys, Quay, do you see this file already, or do I have to create those? Yeah. Yep, 4-10. I thought they were already in there for us, but if not, sometimes mine looks a little different. That's why I was curious. It should let us use them. It's probably just on mine that it's not letting you use it. Let me look when I go to. That's gonna. Okay, they don't have. Okay, you don't show the. Okay. Oh, so it creates those files on the fly. That's what I was looking at here. Okay. All right. So that's okay. So we know that at least it passed it to this point. So let's look at this idea of what we have here. So if I get those files and it actually prints them then on the fly, or does them. There we go. All right. So what it should be comparing is the line, this is text, to this is text. And so what this should result in is saying, hey, that it prints out an equals. Well, we need to figure out a way to get through this entire set of files, so where it's going to compare all of those together. So I like the read line. We're able to compare one line or another, but how do we then get through the entire file? So let's think about this. In between this space here, we need to really put this into some kind of a loop that each time it will read those and say, hey, that's a new piece of code. How do I think about that? So easiest thing, we don't know how many lines are in there, and we're going to read them individually. So I would say we do some kind of a while loop. So while what? So that's where we think about how do we come up with those. So here's my suggestion, or a thought that might work. So we're reading through those files, and when we get to the end of those files, it's going to return a blank. And so at the end of one, it's going to be blank, and it's going to return another one that's going to be blank. And so one way I might create this loop is while those conditions are not true, while line 1 does not equal 0, or does not equal a blank. So we can do that. So while line does not equal, and line 2 is not equal to blank. So you're going to have to figure out the right syntax for that. I'm not going to give you every piece of that. But what we're looking for then, and there's a ton of different ways you can do this. So while line 1 is not equal to a blank, and line 2 is not equal to a blank. So as long as those conditions are not true, this while loop will still continue to function. Does that make sense? And so then this actually goes inside of that loop. So each time that loop fires, it grabs a new line of code out of those two files. So this would go further in, because those are all going to be. And I will say, in a really good Python editor, you can, and maybe there's a way to do it in this, I have not tried, you can grab that entire line and move the whole thing forward. So here we have our if. All right, so I'm going to go back to my instructions. If they are, the script should simply output yes. If they are not the same, the output should be no, followed by the first lines of each file that differ from each other. So this would go all the way through there, and then it would print out, in this case we want yes, not equal. That should be no. All right, so we're getting a little closer. So it's going to take those two files, and as long as we haven't reached the end of file for both of them, then we should be able to do that. So if it's no, the other piece we need to do then is print. How does it say to print them? Does it say followed by the first line? So we can do it in two different ones. So line 1 and print line 2. All right. Now, there's some other tweaking you might have to do in here. But so we need to clean up this line to make that the correct symbols and syntax for Python. This says we're going to read those input lines in, and it's going to print out that. Now, the other thing that needs to happen, or should happen, or as a thought, is we might be able to use another function in here. And so it's not my favorite way to do it, but we need some way out of here. So if we make it all the way through this file, I need to be able to print out the yes or the no. If it's no, I don't need to continue the rest of the function. So there are a lot of other ways to do this. This is probably kind of a cheaty, easy way to do it. Once I hit the end of this, it executes out of that loop. And so you could put in some text that says print, sorry, the lines did something, or thank you, using our program. So to show that we come back out of this loop. So there's two different ways it can come out. It can come out because we reach the end of it and it's always been yes, or we reach the no and it kicks it out. And if it's no, it prints line 1 and line 2. So is this the only way to do this? Oh, heavens no. There are millions of different ways to configure that. This is just when I'm sitting here looking at it, kind of my first choice at that. The other thing what we want to do, input file 1 dot close. So we'd like to make sure we close both of those. So just kind of that programming finishing. So if you have the gist of this, that should be really close. Now, if I try to run this, let me show you what's going to happen. It's going to give me a big bad. So it creates it. 3 of 5 checks passed. Well, all right. Doesn't quite work. So it does grab the files. It does open them. But the way I've got it written, it doesn't necessarily look at the correct output. And part of that is because it's stopping at this line right here. So, but these can be helpful to show you what's going on. So expected output, yes. It didn't give us that expected output. So if I run it over here, you're going to run into the same error. It's going to give you a syntax error. So you need to correct this, and there's a little bit of tweaking you might want to do here. A couple of things to remember. Double equals lines for equals. A single one is an assignment operator saying it's equal to that value. So there are some tweaks that you can do. You could rechange how this loop runs. There are a myriad number of ways to do this. You could run a definitive number of loops. If you used some manipulation, you could load that entire text file and you could actually get the number of lines in it. You could do it that way. You can do there are some end of file other techniques you could use. So this is very subject to change, but this is one possibility of a way to do it. It also is a little interesting because here, while the program says you're going to print a yes at the end, here you're actually printing a yes for every line. So there might be something you want to look at. Is there a way to do this only if this condition happens and this? So you might even move that outside of there some way. All right, so that is 4-10. We will look at a couple of other ones on Thursday, including the discussion board, because there is an assignment in the discussion board we want to look at and see if we can come up with a way to create that. All right.